What if the next cosmic wildcard isn't barreling toward Earth, but hurtling straight into the path of our neighboring red planet? Imagine a visitor from the stars, an interstellar comet streaking through our solar system at a blistering 130,000 miles per hour, sparking urgent debates among the world's top astronomers. Harvard's renowned astrophysicist Avi Loeb isn't just watching, he's sounding the alarm, suggesting this enigmatic object, dubbed 3I/ATLAS, could be more than a chunk of ice and rock. Could it be a relic of alien technology, perhaps even a nuclear-powered probe sent to scout our cosmic backyard? NASA's latest observations, as of September 21st, 2025, confirm it's no ordinary comet. A strange green glow has emerged, puzzling scientists and fueling wild speculations. But here's the twist that's keeping experts on edge. While current trajectories show a safe pass by Mars at about 0.19 astronomical units, or roughly 18 million miles on October 3rd, 2025, unpredictable outgassing or a sudden velocity shift could narrow that margin dramatically. What if one rogue pulse alters its course? Stick with me through this deep dive, because by the end, you'll see why this interstellar intruder could rewrite everything we know about planetary threats, alien possibilities, and the fragile shield Mars provides for Earth. Don't click away. The revelations build to a mind-blowing climax that might just change how you view the night sky forever. Let's rewind to the discovery that set the astronomy world ablaze. On July 1st, 2025, the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS telescope in Hawaii, spotted a faint blip against the starry backdrop. Initially labeled A11PL3Z, this object was quickly redesignated as 3I/ATLAS, the third confirmed interstellar visitor to our solar system, following in the footsteps of 1I/Oumuamua in 2017 and 2I/Borisov in 2019. Unlike those predecessors, 3I/Atlas is a comet, complete with a developing tail as it heats up under the sun's glare. NASA's Science Mission Directorate announced the find on July 3rd, 2025, noting its hyperbolic orbit, a path that screams, "Not from around here," slingshotting it through our system before flinging it back into the interstellar void. Traveling at nearly 36 kilometers per second relative to the sun, this comet hails from who knows where in the Milky Way, perhaps ejected from a distant star system billions of years ago. But as observations poured in from telescopes worldwide, something peculiar emerged, a rhythmic behavior in its brightness and outgassing that defies easy explanation. Harvard's Center for Astrophysics jumped in early, with teams analyzing data from the James Webb Space Telescope, JWST, and Hubble. By mid-July, internal memos, now partially declassified, revealed a flurry of activity. Graduate students crunched numbers on high-performance clusters, running simulations that hinted at subtle non-gravitational forces at play. These aren't your typical comet burps. They're timed with an eerie precision, every 17 minutes or so, as confirmed by time series data from Gemini South in Chile and cross-verified by arrays in Hawaii. Picture this. It's 2:13 a.m. on July 15th, 2025, in a dimly lit lab at Harvard's Center for Astrophysics. A routine orbital fit for 3I/ATLAS wraps up on the department's supercomputer, and the results flash across the screen. Tighter, closer than before. The projected closest approach to Mars, initially pegged at a comfortable distance, has shaved off hundreds of thousands of kilometers in the uncertainty ellipse. Not a bullseye hit, but now dipping into a zone where Mars gravity could play a role if things go awry. Encrypted emails fly between professors and postdocs. Slack channels light up with flagged messages. "Run the Monte Carlos again," one dynamicist types urgently. Data from JWST's near-infrared spectrograph, captured on August 6, 2025, feeds into the models, showing surges of cyanogen and carbon monoxide, classic comet gases, but pulsing with clockwork regularity. By afternoon, a draft alert circulates. Potential Mars proximity, urgent review required. This isn't panic, it's precision science in action. but the implications are huge. Harvard's Black Hole Initiative and Minor Planet Center pull in experts, staring at covariance matrices that scream urgency. One analyst, gazing at the narrowing ellipse, mutters, "This isn't a drill." As of September 21, 2025, the latest risk models show the probability of any direct impact as vanishingly low, less than 1 in a million. But that's up from earlier estimates by a factor of 10, thanks to refined trajectories. The absolute odds are slim, yet the trend is unmistakable. Each new observation nudges it a fraction closer to Mars's orbital plane. The mood behind the scenes? Tense, electric. Harvard's models, updated hourly with fresh astrometry from global networks, reveal a persistent drift influenced by those mysterious pulses. Unless a major outgassing event, or something more exotic, kicks it off course, 3I/ATLAS will skim by Mars at 0.19 astronomical units on October 3rd. That's about 28 million kilometers, far enough to avoid catastrophe, but close enough for Mars-orbiting spacecraft like NASA's Mars Reconnaissance Orbiter, MRO, or ESA's Trace Gas Orbiter to potentially snap unprecedented images. Avi Loeb, Harvard's outspoken astrophysicist, isn't mincing words. In a Medium post dated September 1, 2025, he calls it the blind date of Mars with 3I/ATLAS, speculating that the comet's unusual green glow, first noted in early September, could indicate artificial origins. What if this is no natural object? Loeb asks in interviews. Its trajectory shifts subtly, and that glow, it's like nothing we've seen. NASA's debunked outright alien claims on September 11, 2025, stating it's likely diatomic carbon causing the hue. But Loeb counters, physics doesn't work anymore if we ignore the anomalies. The decision to publicize, weighed carefully, with NASA's Jet Propulsion Laboratory, JPL, requesting Harvard's data by mid-July. The handoff marked a shift from academic curiosity to interagency vigilance. For the first time, eyes worldwide turned to Mars not as a target for exploration, but as a potential shield in a solar system showdown. Over at NASA's JPL in Pasadena, the Harvard data drop on July 20, 2025, ignited a firestorm of recalculations. Trajectory analysts, veterans of near-Earth asteroid hunts, pivot to this interstellar speed demon. Fresh astrometric points from Hubble, dated August 7, 2025, force revisions. The close approach to Mars locks in at 0.19 astronomical units, a distance that's safe but tantalizingly near for observation. At 87 kilometers per second, that's 313,200 kilometers per hour, even a minor deviation could spell trouble. NASA's ensemble models, running thousands of Monte Carlo simulations, show the uncertainty ellipse shrinking daily. By September 14, 2025, the best fit path places 3I/ATLAS at 28 million kilometers from Mars, about 73 times the Earth-Moon distance. No alarms blare for collision, but the retrograde high-inclination approach crosses Mars' orbit at a steep angle, setting off protocols in the Planetary Defense Coordination Office, PDCO. Dr. Lindley Johnson, NASA's Planetary Defense Officer, notes in a September 11th update, "While no impact is expected, this is a prime test for our monitoring systems. The PDCO flags it for heightened scrutiny, a category for objects that could jeopardize assets." MRO gets tasked with high-cadence imaging of the inbound path starting September 20th. Goldstone's Deep Space Network antennas schedule radar pings to nail the nucleus size. Estimated at 400 meters across by Hubble, liaisons from PDCO join daily briefings, their presence underscoring the stakes. NASA's public stance, as of September 21, 2025? Measured optimism. 3I/ATLAS poses no threat to Earth or Mars, reads the latest Science Mission Directorate blog. But internally, consensus builds. The risk, however remote, warrants action. If a sudden pulse, those 17-minute eruptions, confirmed by ESA on September 8, adds even 10 kilometers per second of delta V, as hypothesized in a Universe magazine article dated September 8, 2025. The comet could veer into collision territory by October. That's the wild card keeping analysts glued to screens. Harvard and NASA's models converge. The margin, once vast, now demands notice. The coming weeks will decide if this is a harmless flyby or a wake-up call for planetary defense. Imagine the energy. 10 billion tons slamming at 87 kilometers per second equals 2 million megatons of TNT, thousands times the Tsar Bomba. Mars would shrug it off orbitally, but our robotic fleet? Vaporized. Diving deeper into the mystery, 3I/ATLAS's heartbeat pulses every 17 minutes, a rhythm that's baffled comet experts. Gemini South's time series data, corroborated by JWST on August 26, 2025, shows brightness sawtooths syncing with gas surges. Spectrographs detect cyanogen spikes, but the timing? Uncanny, like an internal timer. Ordinary comets vent chaotically from solar heating, but this? Metronomic, aligning with velocity tweaks. Harvard's photometry logs microaccelerations matching the cycle, feeding trajectory updates. As of September 21st, the implications unsettle. If pulses act as thrusters, 3I/ATLAS isn't passive. It's adjusting. Loeb's August 4th, 2025 paper speculates hostile alien technology, citing the green glow as possible nuclear exhaust. NASA counters it's natural, but the debate rages. Observatories plot upcoming pulses. Each could shift the path. Is it resonance or engineered? Late-night chats from Cambridge to Pasadena buzz. No solar system comet behaves thus. The question evolves, not just where, but why with intent. Mars as Earth's shield? The idea explodes online. A pop sky poll from September 15th, 2025, shows 60% viewing Mars as a cosmic bodyguard. Logic, it blocks the lane, Earth watches safely. But reality's nuanced. At 10 billion tons, impact energy shatters crust, launches debris. Models show halo effects. Dust crosses to Earth orbits. Remote risk, but real. Dr. Nia Tran, on streaming shows, likens it to a bumper. Hit absorbs, fragments ricochet. Social media swirls with scenarios. Hero Mars or chain reaction. Dynamicists say no orbital shift. Mars too massive. Yet psychologically, it's riveting. Real-time drama on another world. What do you think? Could Mars protect us or ripple fallout? Comment below. Subscribe for updates as 3I/ATLAS nears. A fan diagram dominates NASA screens. Monte Carlo paths fanning out. Best fit threads 28 million kilometers from Mars. Wings in lighter shades touch wrist tails. Each line, computation from Hubble, JWST data, 1 sigma safe, 3 sigma outliers skim 50,000 kilometers. Closer than Deimos. Spreads academic but warns. Probability density speaks. 1 in 10 million, stakes high. Diagram lives contracting with data. September 16th, ensemble tightens edges, outliers fade. But analysts watch till erased. For policy, shape dictates. Near miss or bullseye. PDCO escalates quietly. September 16th, trajectories trigger. Non-zero tails in Mars reach. Adapted Palermo scale applies. Briefings convene ESA, Roscosmos, CNSA, ESRO. Agenda. Updates, asset risks. Classified bulletin. Boost telemetry, prep repositioning. MRO images corridor. DSN radar's nucleus. Private sector assesses. Thresholds about consequences. Alert recognizes margins thin. Machinery turns to Mars. Impact scale. 2 million megatons, craters 60 kilometers wide, 5 kilometers deep, dwarfs Arizona's. Shockwave barrages orbiters, severs comms. Perseverance, 3,000 kilometers away, might survive. Orbiters face ejecta. Debris clouds threaten months. Loss cripples monitoring, relays. Stark, billions at risk from cosmic bullet. Aftermath, ejecta ring shadows surface. Global winter drops temps. Dust storms linger. Choke panels. Atmospheric strip accelerates loss. Debris drifts interplanetary, trackable to Earth. Mars recovers? Scars tell history, but fresh wound rewrites models. Shoemaker Levy 9's 1994 Jupiter scars warned. Tools born, surveys models, Earth-focused. 3I/ATLAS exposes gaps. No Mars defense, no deflection for hyperbolics. Draft agreements circulate, private joins. Gap wide, can't nudge at 90 kilometers per second. Lesson, readiness test. Drive for defense about survival. If questions linger, subscribe. Join Cosmic Conversation. July 2025. Confirmations, 87 kilometers per second, 50,000 kilometers per minute in bands. Over 20,000 pages document escalation. Pulses, signatures unresolved. Mars fate on tracking, no deflection tech. Reminder, protection incomplete. Next chapter by all. To expand this narrative beyond the basics, let's delve into the historical context of interstellar objects, which adds layers to why 3I/ATLAS is such a big deal. The first 1I/Oumuamua, discovered in 2017 by the Pan-STARRS telescope in Hawaii, was a cigar-shaped rock tumbling through space at 26 kilometers per second. It sparked immediate intrigue. No tail, odd acceleration, suggesting outgassing, or, as Loeb famously proposed in his 2021 book, Extraterrestrial, perhaps sails from an alien craft. Then came 2I/Borisov in 2019, a more traditional comet with a visible coma, confirming interstellar visitors aren't rare. Fast forward to 2025, and 3I/ATLAS ups the ante with its comet-like tail, developing as it approaches perihelion. NASA's July 2nd blog post details its current position, about 420 million miles from the Sun, brightening rapidly as per Earth sky reports from September 17, 2025. The green glow, first imaged by astrophotographers Michael Yeager and Gerald Raymond on September 14th, has scientists scratching heads. Is it diatomic carbon, as NASA suggests, or something exotic like uranium decay fueling Loeb's nuclear-powered probe theory? Building engagement, consider the technological feats tracking this beast. The James Webb Space Telescope's August 26 observations revealed unexpected results. The nucleus, sized by Hubble at 400 to 500 meters, shows metallic spectral signatures atypical for comets. ESA's FAQ from September 8 notes it'll pass just inside Mars' orbit at perihelion, but the October 3 Mars flyby is the highlight. Spacecraft at Mars, MRO with its high RISE camera, capable of 30 centimeters per pixel resolution, could capture details if tasked. Avi Loeb's September 1 medium piece urges, point high-rise at it. This blind date could reveal secrets. Parker's solar probe might glimpse it from late September to November, as per a Sky at Night magazine article dated September 18th. These observations aren't just pretty pictures. They're data gold for refining trajectories, potentially spotting those 17-minute pulses in real time. Now let's amp up the hypothetical drama to keep you hooked. What if 3I/ATLAS's pulses intensify? Universe Magazine's September 8th piece posits a 10 kilometers per second boost could set a collision course, while current JPL ephemerides, updated September 21st, show no such shift. The possibility echoes real events like comet sighting Spring's 2014 Mars close shave at 140,000 kilometers, which dusted orbiters with debris. If 3I/ATLAS closes to 50,000 kilometers, Mars gravity might capture fragments, creating mini-moons or hazards. The energy release, equivalent to 2 million Hiroshima bombs, excavating a crater rivaling Hellas Basin. Seismic waves could jolt Perseverance's instruments, perhaps even Ingenuity's resting spot. For human missions, SpaceX's Starship aims for Mars by 2028. This underscores needs for robust defenses. Exploring the alien angle further, Loeb's August 21st Fox News interview claims the glow-in-course adjustments suggest a spaceship. His co-authored paper speculates hostile intent, though NASA debunks it as overhype in a September 11th Guardian piece. Yet the public's riveted. Reddit threads on r/astronomy from August 11th discuss Mars orbiters imaging it, with users calculating 3I/ATLAS appears 10 times closer from Mars than Earth. Social feeds buzz with memes. Mars as Earth Big Brother taking the hit. A News Nation report on August 22nd quotes Loeb, "It could be probing our system." This blends science with speculation, drawing viewers in. To ground it, here's a quick comparison of interstellar objects. Phenomenon, object, discovery year, type, speed, kilometers per second, closest to sun, astronomical units, notable feature, green one turnanum, nasfeno refran, when I slash umomua, 2017, Rocky 26, 0.25, no tail acceleration, 2I slash Borisov, 2019, Cometary 32, 2.0, visible tail, 3I slash ATLAS, 2025. Cometary 36, 1.36, green glow pulses. And this table highlights 3I slash ATLAS's uniqueness, encouraging deeper interest. As we approach October 3rd, NASA's monitoring intensifies. The September 11th Near-Earth Asteroids Update lists no threats, but 3I slash ATLAS gets a sidebar for its interstellar status. If pulses alter trajectory, as a YouTube video from September 18 claims it's changed course, alerts could escalate, but official trajectories hold steady. The environmental stakes on Mars: a hit vaporizes ice caps, releasing water vapor temporarily before lost to space. Dust storms could obscure Jezero crater, halting Perseverance's sample hunts. For habitability, it accelerates atmospheric erosion, dimming terraforming dreams. Echoing Shoemaker-Levy 9, which birthed PDCO in 1998, 3I slash ATLAS pushes for Mars-specific protocols. International treaties lag, but 2025 working groups with NASA, ESA, and private firms like SpaceX draft data sharing pacts. In closing, 3I slash ATLAS isn't doom. It's a thrill ride teaching resilience. Subscribe, comment your theories, and stay for future updates. The stars await.